Hi, good afternoon, everyone. I'm Oliver Gao. I'm the director of Cornell System Engineering Program. I have been very fortunate to conduct what I call this system conversation with our esteemed speakers we bring to our program to talk about the research and also their thoughts on the frontiers of system engineering. So today, I'm very honored and delighted to invite you together to talk with Professor Ranah Zadeh. Rana is a professor and also the co-director and co-founder of the Health Design Innovations Lab in the Department of Design and Environmental Analysis at University. So, Rana is one of us. And her team has received the Innovation Incubator Award and also the Nobel Technology Award from the Clinical and Translational Science Center and Weill Cornell Medical College. She has received a line of awards and also recognitions. I'll be brief here, because I know we want to know more about Rana herself. So Rana, welcome to this conversation, and it's a great pleasure to have this opportunity to talk with you. When we look at your research, your career path, I noticed, you have really gone through a very wide spectrum of experience and training, and now get to this point where you are really integrating so many seemingly disconnected aspects together to help our society. So I'm curious, and I believe a lot of us are curious. We want to learn how your career evolved and developed, and what brought you up to here at this point today.
Thank you so much, Oliver. At first, let me start by thanking you for having me for this very interesting conversation series. And it has been very interesting. It has been a great pleasure to interact with the Systems Engineering Department.
Thank
So about my career, yeah, as you know, I started in the field of architecture. I then pursued the area of health systems design. And in the past 8 years, I have been focusing on healthcare and very recently on healthy aging. So it has been a journey. So I'll share how it started for me. Hopefully, it will be interesting or inspire our other future leaders and our students. So I became fascinated by architecture in the beginning because I was interested in how it affected our minds and our kind of when you are around the vernacular architecture, when it has harmony and peace, it really makes you feel good. So I pursued the field of architecture because I wanted to create environments that provide comfort and healing.
you.
So that's what I pursued. And then I went to become an architect and went to practice. My education in architecture was a traditional way of studying architecture. All my classmates and everyone I interacted with was in the same field. But today, education is a lot different. As you know, for in institutions like Cornell, we all interact across disciplines. So when I graduated, I didn't have a lot of experience or exposure to working across disciplines. When I went to practice, then for the first time, I experienced working with engineers, working with owners and clients, people who make business decisions. What I had learned in my architecture education was the architect ideating, creating a vision, an idea, which would be a beautiful one, a hope for health, for quality of life, for good experiences for the user. So that's how you would start in architecture. But when you look at practice, you will see many of the ideations and concepts of design and architecture really don't come to practice. Many of them pause at the drawing, at the paper level. So that always fascinated me that why can't we go further? Why can't we do more? Why can't we bring some of these to impact? In practice, was when I realized all these different layers, the engineering, the finances, the human aspects, and the natural practical barriers that we might be facing. Um, Particularly, I remember, so there are some things that you really feel strongly about. For example, in a project that I was involved in designing a health clinic, I felt very strongly about some of the aspects of the environment that would help the patients, that would help the family members who were waiting in the waiting areas, for the patients, and for the caregivers. So I felt very strongly about some of the investments that had to be made for the design to be a certain way. And in my interactions with owners and clients, they asked me about analytical parts of this. They said, how do we get a return on our investment? How do we make sure this actually changes the performance of our business? Having been traditionally trained in the field of architecture, I didn't have a response. So those experiences taught me I wasn't equipped to bring the best ideas I had to the homes of people, to the living environments of people. So I went back to school. I remember I joined a health systems research center at Texas A&M, and I remember a class that particularly motivated and really inspired me was a course by Roger Ulrich. He was an environmental psychologist, and he shared data and analytical results of how decisions about the environment will change our psychological and physiological outcomes. So, for example, he showed just like how physicians with prescription of medication change health outcomes, actually the way the environment is and created, and as we are exposed to different environments, our life trajectories, our health patterns could vary based on the environments around us. Examples of that was randomized controlled trials in hospitals showing patients who have exposure to beautiful views versus those who have exposure to a brick wall had 20% less pain, 20% consumed less pain medication. Another examples of studies showing indoor environments, spaces that we are in for 90% of our lives, could have potentially, if designed properly with daylight, they could have antidepressant effects, even more than the medication. So here's an opportunity for those who form and shape the environments and products around people, who contribute to the social, physical, psychological well-being of people. So that those types of research studies were really fascinating to me. Can I really measure? Can I really understand the analytical outcomes of decisions about the environment and products on people? The other question I had was, if I know those information, if there is research that can show us what is good design, how does it impact outcomes? Are there information about how to communicate this to owners and clients? Does this really change the bottom line for the organizations? Or is it just a luxury? So for that reason, I pursued my interest further. And as a result of that, I became familiar with systems approach, because then you really, if you really care about the user and the quality of living and the quality of healing experience, if for example in healthcare or education in schools, then you would realize spaces and environments where I was specialized in the beginning of my career are not the only aspects that affect their outcomes and their organization's outcomes. What I learned was, if how they work together with other dimensions of the system and how they are maintained over time through operations and management really matters in how we create effective environments and products and processes for people. How can I be more effective then in supporting health, in supporting quality of life? The answer really was lying in this. The answer was working together with the other stakeholders, with the other experts. So today, as I work with my students and colleagues and collaborators, the boundaries of disciplines of medicine, engineering, social and behavioral sciences, nursing, business, they're all blurred, global health, etc. Because as we all sit together, we put our heads together, we look at different elements and different aspects of how we can improve the outcomes for the user from all the different perspectives. And then, in addition to that, we study and we measure so that we can share the impact, so we can inform, but also understand the business outcomes so that we can make a difference, so that we can communicate the good solutions to decision makers.
That's wonderful. Thank you, Rana. So, when you were talking about this, it's really very inspirational, and also it kind of get people to think about. Of course, you started as a architect, right? And then, but it's and then you expanded all this work into health. Actually, this kind of reminded us. So, what is the purpose and what is the role of one profession, like like architecture or even engineering? Because I think one of the key focus of your research is really is really concerning health, right? And I think my work, of course, look at the transportation and air quality and how that impact health. But I think we are addressing the different aspects of how the built environment affect our health. So speaking of this, um, if you even think, bigger, architecture is not only, for example, the design, either internal or external design of one building. It's really like, the whole system, because this whole system will affect like the exposure. What I found out, three factors affect our health: genome, phenome, and exposome. So this exposome is really, I think, what you and I we're trying to look at. So here, of course, I want to expand this discussion a little bit regarding health. I think you have made wonderful effort to improve the design of either buildings or structures, or the internal and external design to improve the experience of people, and especially for patients when they visit hospitals.
Mhm.
Uh, right. That somehow seems to me, you are trying to improve the design to help people who are already sick and they need to be cured. So what's your thought about like architecting in helping prevent people from getting sick? So because I think, architecture and together with, infrastructure, a big part of it is also coming out from the planners and architects. If you think a bigger picture, how can we, by improving or change our design philosophy of our urban infrastructure, how can we prevent people from getting sick? Because I believe preventive cost should be much lower than the curing cost.
Mhm. Absolutely. You really hit the nail on the head, Oliver. And I know that from an environmental health perspective, you have been looking at it from engineering aspect. So, really important point you just mention. So I want to share two key topics. One is um, health. If you ask a physician um, or a nurse or a clinician, traditionally, how do we improve health? The answer may be okay, well, if there is a disease, we treat it with medication or um, certain treatment, invasive treatments or medical treatment, pharmacological treatment, right? So that may be a clinical approach. But if you ask an engineer, how do you improve health? Or if you ask an architect, how do you improve health? If you ask a global health researcher, how do you improve health? Each of these fields will provide you a different answer. But what is health and well-being? I think it's the number one thing you and I and our families and us as a society we care about, to have good health and live in good quality of life. So the scientific answer to that is health is the combination of all. And it's really interesting when you look at the data, you see the clinical um, interventions, the clinical solutions, what we generally categorize as health, is only maximum 20% of our health and health experience. The other 80% really comes the social, economical factors, the health behaviors, the environments, processes, and places around us. So all that comprise the 80%. So to achieve maximum health, that means engineers and designers and economists, all of them must now become contributors to health and work hand in hand with clinicians and with people to make sure that the quality of health is delivered. So that multidimensional aspect of health is quite overlooked, but gladly now multidisciplinary researchers are bringing attention to this topic. So hopefully we will fill the gap with where we are and where we need to be in providing good health for the community and for people. The second point I want to mention, Oliver, when you really made a very, very important point, and you said we need to focus on prevention. Uh, so when disease comes, as you know, that's when we fail, right? To a certain extent, according to the World Health Organization, major portions of disease onset or disease progression is avoidable and preventable. And the causes of those lie within the environment, lie within our habits, health behaviors. And if we adapt proper behaviors, if we live in proper environments surrounded with the right tools and processes we need, it is very likely that we prevent many of those. In the systems engineering talk, we talked about heart disease and cancer, top two causes of mortality in the United States. Many of those preventable. For example, right lifestyle changes, behavior changes, preventing stroke or preventing heart disease. Um, many and so prevention and health promotion becomes a life course question. How do we change behavior? How do we promote healthy behavior? Um, it really, the answer lies within the environment we live in and the resources that we have. Um, how do we encourage people to go out, move around? How do we facilitate those people who already have disabilities, who already have limitations, to live to their maximum potential and delay their progression of their disease? It really makes a huge difference. The products, places and environments, technologies, and resources and programs around those people really makes a difference, whether or not they live a prosperous, healthy, and independent life, or if they become further paralyzed and dependent, and those cognitive or physical limitations become a barrier to their growth. So really the work that we do and engineers, researchers, clinicians, public health workers do around the world can make a huge difference. And to bring this, to improve, to encourage people to promote healthy behavior and to help them achieve their maximum potential.
Wonderful. So, Rana, when we talk about this, it seems like it's kind of for you and me, we are ordinary people. It doesn't seem to be hard for us to get the concepts and agree with those concepts that you and me, we just talked about. Right. And speaking of this, about 2 years ago, after I started teaching this course, systems architecting, serial practice of systems architecture. And I realized that actually the system architecture has so much to do with the real architecture, like you design like for building or something. So that kind of lead me to a belief that actually the architects are really very good systems engineers. I would call architects are really human systems engineers, because you start by identifying the human needs, right, and then translate their needs into their requirement for a certain design. And you identify the functional requirement, and then you convert all these functional requirements of code that doesn't exist before at all. You convert that into a form that are showing all the real components of. So you are really what I call a human systems engineer. Now coming back, I said earlier, like it's kind of a holistic approach, especially for example by designing our living environment with health very well considered in our design. That seems to be a no-brainer when we build our cities, build our places. However, now look at all the cities out there we have, right? So New York City, New Delhi, Singapore, Tokyo, and all these cities we end up today, they did not seem to follow the very simple philosophy that you and I just shared among us. So what happened? So you can say, well, I'm trying to ask that, it doesn't seem to be a very hard philosophy for everyone to recognize. However, the reality seems to be on the other end of the spectrum. In our cities, our living places, did not designed in a way that that you just talk about. What brought us there? When this pandemic, when all this happened, right? The human beings, while in the good times we seem to be very robust and resilient, but in these hard times, we really see the vulnerability of our human lives. Especially in front of the not very well laid out and designed urban living environment. So what brought us here? You maybe you have some insights.
You bring a great point, Oliver, and reminds me, communities and cities play such an important role for our health and well-being. They're such an important factor. As we age, older person, their ability to get around, to be able to maintain their health, to be able to continue to have social connections, to be able to contribute, these elements that World Health Organization defines as overall health and healthy aging, all of these relies on the community. In the US, we many neighborhoods we live in, some of them don't even have a sidewalk, right? It may be very difficult for someone who doesn't drive to go get groceries. So we have these environmental barriers. In research, we talk about nature and the role of greenery in health, some of your research about environmental health and air and talking about these elements in the community, how important it is for overall health, for life course, but also aging. But you make a really good point. We already know this in research, has been known for decades. But when we look around us, why there is so much variation in our success to bring research to change our daily lives?
Mm-hmm.
That is a very good question. And that is a point we all need to work together to make a transformational change. In the systems engineering department, you guys talk about complex systems, talk about interfaces, talking about stakeholders, and the processes to make complex systems work. Topics like aviation, transportation, these complex systems making happen. I think we really need to bring those experiences into health. We really need to translate um, our learning experiences in build, solving complex problems into solving the problem of our health and quality of life in a day-to-day basis. And that is such an important issue, as World Health Organization highlights, saying the gap between what we know and what we have in our day-to-day life is way larger. It's actually huge, sometimes decades of, sometimes 100 years between what we know and what comes to practice. It's much larger gap compared to what we know and what we don't know. That's where the science and theory expands, right? So translation to real world, it's a huge barrier. And Oliver, I would be interested to hear your perspective. What I have learned and have observed is, well, we have so many stakeholders. We have the user, the community providers, the local authorities, the health authorities, the government, the people who provide the finances. How do we improve our communication around all of these stakeholders and their incentives? How do we make sure they're all aligned? The incentives are all aligned. And hopefully, with the new generation that has been educated by these systems approach, systems thinking, that they understand the effect of various decisions, various investments, various policy decisions on not only different processes, but also people's health. Hopefully, those multidisciplinary thinkers start a more bottom up transformation. But I would be curious from your perspective, Oliver, what do you think some of the barriers are from practice to impact?
Excellent, Rana. And I think in this kind of my perspective, actually, I think when you were talking, you already mentioned several very good keywords that will relate to my perspective. For example, you mentioned alignment. Like you mentioned, multidisciplinary. Actually, this can actually lead us to think further about what really system engineering is about. So one thing, of course, we say, system engineering is taking a holistic approach. System engineering is trying to look at the emergent behavior when you have complex system, consistent multi components. These are all these different things. But one thing I realized that system engineering can help benefit the human society as a whole. It's really that system engineering can help people realize what they believe to be true, to be their goal before, turn out to be wrong. Let me expand it a little bit. Because, one thing, for example, taking city development as an example, like in reality, of course, reality is far from what you and I would like it to be. You and I, we're in the Ivy Tower, we can talk about, okay, what the cities should be like. Of course, you had some, real world practical experience. You work probably with different stakeholders. You realize even in the city development projects, right?
Mm-hmm.
And even you as a very health conscious researcher, you would advocate for the consideration of the health dimension in all these development decisions.
Mm-hmm.
But in the end, keep in mind that you are probably fighting an uphill battle with developers.
Exactly.
In their mind, right? They're considering profit. They're considering rate of return,
Mm-hmm.
such that in comparison to their dimensions and your voice,
Mm-hmm.
um, is ignored or overlooked.
Mm-hmm.
That's a reality. So as a result, that's not only in the developers, and even if you look at a lot of federal, state, municipal government decision makings, right? They want to design something that is operating in an optimal way. They want it to be very high efficiency, and also they want to achieve such high efficiency with a minimal cost, the best
Mm-hmm.
economic efficiency. But because in all their decision making, in all the criteria they are trying to follow, where is human health? Where is
Mm-hmm.
health? So a lot of times, this kind of environmental or health consideration becomes like a kind of the best. It becomes a baddie,
Mm-hmm.
and the worst it becomes, some kind of cosmetic
Mm-hmm.
they use. It's sad, but it's a reality. So what I'm trying to say is that actually taking a systems engineering approach and looking specifically and also asking in depth what exactly the stakeholders and what exactly the stakeholders should be wanting
Mm-hmm.
out of a project, such that their decision making is no longer just cost minimization, profit maximization. Instead, they have multiple objectives,
Exactly.
such that in the end, and also again, even these aspects are not hard for decision makers, for people to agree with us. However, I think our ideas are going up against the main frame, the main flow, and within this main flow, and all the professional practitioners, decision makers, and even users, including us, we are in this main flow. We have been used being in this main flow such that we don't even have time to stop and think about these questions that you and I were asking.
Mm-hmm.
What I call this the wrong paradigm. We are in the wrong paradigm.
Paradigm.
The wrong paradigm that was set up consciously or unconsciously
Mm-hmm.
in the history that now becomes the dominant flow, like a tide carrying
Mm-hmm.
all these stakeholders, like moving forward, either without time to think or without the intention
Mm-hmm.
about this. So I feel, if because you look at this, to implement those ideas that you just shared, it's actually not too hard. It's just that people didn't
Mm-hmm.
have the will or even realize the need
Mm-hmm.
to implement these things. So it's not really the problem of technology or even some design philosophy. It's really
Yes.
how can we, through our power, how can we, as you said, translate our philosophy, our ideas into some knowledge and practice that can be adopted and embraced by the real world, practice. That's a hard problem. I don't even know the answer myself, but I do agree with you. By taking systems engineering approach that will at least help us realize,
Mm-hmm.
oh, we were in the wrong paradigm.
Exactly. And we are living with those consequences of, the gaps that you just described. It is affecting our lives and our lives of our loved ones. And it's very interesting because systems engineering's um, role is to bring to practice, is to make available engineering and environmental solutions and behavioral solutions work for practice. So it's a unique time for systems thinking, because that's the gap, that is the answer to move us forward. Because with the systems approach, we can now understand the partnership that can be made among the policymakers
Mhm.
and the community representatives and the developers and the investors and the engineers. That's how we can really put our heads together. You brought some really important point about the incentives. The incentives, for example, right now we talked about the community, right? Let's
Yes.
say we have a community, and right now with unfortunately, if we don't have sufficient regulations, and that development is passed to a developer for a short time, the developer's stake is only from the time of construction to selling the land or the property. So the continuation of living in that piece of land for the life course, for the generations to come, for the kids and younger people, adolescents and adults, all the way to aging and hopefully aging in place, that part really does not become an incentive or interest of the developer. So what, just like as you explained, now from that perspective, if you're segregated as contributors to this creation of life, creation of living environment, creation of living experiences, if we are segregated in our incentives, then the definition of efficiency for the developer will be the maximum return at the point of sales, right? But like as you described, the stakes are different. Now we realize the major cost to our society is actually health over life course. Can the developer become a stakeholder, ensuring they create a neighborhood that promotes social connections, that improves safety, that reduces crime, that promotes aging in place? Aging in place, a component that we talk about today nationally and internationally as one of the key topics to promote health and reduce costs. So if we all partner together, if the policymaker, investor, the developer, and even the community health provider, we if we had the knowledge, if we had the exposure to how to what needs to be done, and if we work together, and if the stakes would be aligned, then hopefully we will develop the communities of the future, Oliver, where the the investment is made for a reasonably long-term return, in which the right perspective is built into that analysis of the business analysis. One key term that comes to my mind, Oliver, is the transformation of paradigm from looking at cost to looking at value. The value that the investments bring, both for the investor, but also for the user and the society. So hopefully we are moving toward that direction by the education that is raising emerging leaders, by um, educating future leaders that are extremely aware of these connections. Then they become policymakers and engineers and developers and entrepreneurs that look at the value and look at the long-term benefits, not only those that can be measured quickly, but those that matter a lot and are very costly, but are a little more difficult to measure, a little bit more multidisciplinary systems perspective to really look at.
That's Rana. That's beautiful. You made my last question much easier because I was asking you, right? While we're facing such huge challenges, systems challenges, while we can advocate for system approach, but in the end, we really need people to be equipped with the right paradigm, the right philosophy, and the right tools to do that. So I was going to ask you, in your view, since in this system engineering program, we now have a full spectrum of graduate degree programs. We have a professional degree program, which is Master of Engineering. We have a PhD in systems and also a Master of Science in systems. So I was going to ask you, from your perspective, what would you recommend? What recommendations would you offer to our system students, such that
Mhm.
they can make good use of their stay here at Cornell and take advantage of the Cornell programs? So what would you like to tell them to for them to hopefully carry out the thoughts and ideas you just shared in this video?
Thank you, Oliver. Our systems program is an excellent program. Students get exposed to a variety of angles, work across disciplines, and faculty in the systems program come from a variety of fields. So it's a very unique program. I noticed the students from systems program also come from very diverse fields. Many of them come from engineering. They want to be change makers. They want to make a difference. They want to develop products or solutions that are really effective. And so they join the systems engineering program to understand that larger perspective. One thing that you have promoted in the department, and I think it's very cutting edge, is really the connection between engineering and social behavioral sciences. And I think that with the creation of the multidisciplinary classes and faculty you have developed, you're really communicating that, and Cornell's really communicate that to the students. So our competent engineers and systems engineering students, I think when they see and really experience um, this kind of multidisciplinary angle, because human life, day-to-day conversations, day-to-day lives, really it's about people. So the people sciences um, really will be key for future innovation in systems, because systems engineering will have the tools to bring the cutting edge technology we have across all different fields that we have to bring to real life to change real lives. We can put a man in the moon, but can we improve mobility for older adults in a more effective way? So can we bring these technologies really effectively to day-to-day life for people will be in the hands of our systems engineering students. And by as you know, systems engineering starts with asking the question from the user, and their involvement and what they're learning about the combination of the soft and hard sciences, I think, will be really important in becoming influencing and becoming change makers.
This is Rana. This is beautiful, and I think this beautifully conclude our conversation. And just very quickly, I believe you mentioned all these areas. Of course, in Cornell, we have a very good breadth of the topics covered within the theme that you and I discussed today. And I feel probably I will reach out to you in the future. I think system engineer, we can probably initiate some effort, for example, in like urban systems or community systems engineering or urban technology or urban infrastructure systems. In this domain, we can cross all these areas. There are multiple other members that we can probably work together. But I think that will be a different conversation. But I
Mhm.
thank you again. It's been a very enlightening discussion with you.
Thank you, Oliver. And I also want to thank you, and I want to reflect on my experience the past 6, 7 years that I have had the pleasure to be a part of the systems program, students and faculty. It has been a really fun experience. We sit around the table and we ideate and think about ideas. and we have a faculty member who worked in aviation, now coming up with ideas about healthcare, or somebody in robotics now thinking about, oh, how about we do this to solve problems in a way, this way. So students in systems engineering coming up ideas to prevent infection transfer. So it has been really fun, and working with people across the disciplines that systems engineering department is bringing together, we have been able to play making ideas happen that become exciting for practitioners and has potential for impact. So I'm very excited for our systems engineering students, and also I'm very excited to continue to be a part of your department. Thank you.
Thank you very much. Wish you all the best.
Thank you, Oliver. Have a good day.